Alright, as promised, I wanted to go ahead and show you the proof of the sine rule so that you know that it works. This is really valuable if you're looking at going on to Maths B and Maths C. Learning to prove rules and proving that things are always true is very important in maths, obviously, so we can continue to use those rules and then apply them in other situations. What I'm going to do here is I'm just going to create an altitude, get the height of the triangle there. So just drawing from right angles on the base up to the top angle there. Note again that all the angles are labelled with capitals and all the side lengths are labelled with lowercase letters. Now all I'm going to do is I'm going to find two expressions involving h. I can find the sine of A, that's the sine of this angle here, the opposite side is h for the height of the triangle, and the hypotenuse is c. So sine of A equals h over c, which I can rearrange to c multiplied by sine A equals the height. Now I said I was going to find two expressions. I can do the same thing over here with angle C. I could write the sine of C equals the opposite side as the height of the triangle divided by the hypotenuse, which is A. So I get A multiplied by sine C is also equal to the height. If each of those expressions are equal to the height, I can have C multiplied by sine A must be equal to A sine C. Now, depending on what you want to, which way you want the formula to come about, which way around you want it. So if I'm looking for a side length, I want to keep the side lengths on top. So I'm just going to divide each side by sine A and sine C. So I get C sine A, and as I said, I'm going to divide it by sine A sine C. Some of you will have been able to see this in your head. That's very good. On the right hand side I've got A sine C. I divide it by the same expression, sine A sine C. I've done the same thing to each side. I'm not dividing by 0. So that should be okay. What do we notice? We cancel out the common factor. So on the left hand side that's sine A and sine A. On the right hand side it's sine C and sine C. And lo and behold, I am left with C over sine C equals A over sine A, which we recognise as 2/3 of the sine rule. Of course, if I wanted to get B on sine B, I could just turn that height around and apply it either from angle C or angle A, and I'd be able to show that that's true in all cases. So we know that the sine rule, A on sine A equals B on sine B equals C on sine C, is always true. Are the reciprocals also equal? Well, if I'm looking for an angle, let's keep the angles in the numerator, and I'm going to divide by those side lengths, AC. So here I've got C sine A divided by AC, and on the right hand side I've got A sine C. Dividing by AC gives me the equivalent expression, sine A over A equals sine C over C. And once again we've proved it. Look at that. Nice, quick and easy, but it's worth going over that once or twice just so you can see how proofs work in maths. I hope you enjoyed it. Cheers.